Here in this video, we are solving a CBSE AIPMT 2015 question, which is depending on which is from a chapter called units and dimensions. The problem is this: if dimension of critical velocity of a liquid flowing through a tube is expressed as eta power x, rho power I, and r power z, where eta is coefficient of viscosity, rho is the density of the liquid, and r is the radius of the tube respectively. What are the values of x, y, and z? That's the question, right? So it is simply depending on a concept called principle of homogeneity, where he is telling you that it is given that velocity can be expressed as some constant into that constant has no relevance because we are only talking about dimensions but not physical values. So I'm not writing that here. Eta power of x, density power of y, radius power of z. So I shall know the dimensions of each of these physical quantities and I need to write them here in this equation. I know velocity is rate of change of displacement has the dimensions of Lt power minus 1. Density is defined as mass per unit volume, that is m by L cube, ml power minus 3. Radius is length itself. So finding the dimensions of all this is quite easy, but we need to have some understanding of viscosity to write the dimensions of coefficient of viscosity. What is that understanding that we need is we need to remember that the viscous force is equal to eta area. That is, eta is the proportionality constant here. Area is the area of cross section. Velocity gradient dv by dx. This is the basic definition that we get for viscous force in coefficient of viscosity chapter. To get the dimensional formula of eta, I'm writing that formula here. Here, let's write dimensions on both sides. 4 MA MLT power minus 2. Eta, we don't know. We have to find out the dimensions. Area L square. Change in velocity LT power minus 1 by dx is length. So this length and this length will cancel. Let us keep eta on this side and shift everything to the other side. MLT power minus 2 by L square and T power minus 1. Then it becomes M L power minus 1 and T power minus 1. That's the dimensions of this coefficient. Now, after getting the dimensions of all of them, let us substitute them in this formula that is given for you, right? It is given that velocity is depending on dimensions on eta power of x, density power of y, radius power of z. Let's write dimensions of each of them. Velocity is Lt power minus 1. It means m power of 0. Eta we have found it as m L power minus 1, T power minus 1 whole power of x. Density as mass per unit volume, ml power minus 3 whole power of 5. Radius as L power z. Let's write dimensions of each physical quantity separately, fundamental quantity. Here m power of 1 into x. So in first term, m power of x is there. In second term, m power of 1 into y, that is plus y is there. In third term, there is no m. So there's nothing to write. Similarly, in length, in first term, we are having minus 1 into x minus x. Here we are having minus 3y. Here we are having plus z. Similarly, for the time, we are having t power of here minus x. Here and here in the second and third term, there is no time physical quantity. Left hand side remains the same, m L t power minus 1. Now let us use the principle that we have learned called principle of homogeneity. What is that principle of homogeneity tells you is, in any physics equation, the fundamental physical quantities will have same dimensions on both left hand side and right hand side. That is, powers of these fundamental quantities are same on both sides. So on left hand and right hand side, mass power is, so you can equate all of them. So equating dimensions of mass first. M power of x plus y is there on the left hand side. Right hand side m power 0. So x plus y equal to 0. So x equal to minus y is the one thing that we get. Now let's equate the dimensions of length by equating dimensions of length. What is that? Minus x minus 3y plus z on right hand side. On left hand side, that is equal to 1. But we have found already something, that x equal to minus y. So in the place of this minus x, I can write y. In the place of minus 3y, I will write minus 3y plus z equal to 1. So that I will be I'm able to eliminate x. Minus 2y plus z is equal to 1. That's one equation we have got by equating the lengths, right? And time, by equating dimensions of time. Time on right hand side is minus uh, time. Yeah, minus x. On the left hand side, that is equal to minus 1. Minus x equal to minus 1. That implies x equal to. As you got x equal to 1, you will be automatically getting y is minus x, that is equal to minus 1. I got the values of both x and y. I can substitute them here in the third in this equation. So I can get the value of z as what? What's the equation that we have got? Minus 2y plus z is equal to 1, right? Minus 2 into y value is minus 1 plus z equal to 1. That is 2 plus z equal to 1. Z equal to 1 minus 2, that is minus 1. Then I got the values of x, y, and z, all of them, right? So I can say the relation that we are supposed to have is critical velocity is eta power of x. X value we have got it as 1. Density power of y. Y value we have got it as minus 1. Radius power of z. Z value you have got it as minus 1. So your answer has to be this format, like x equal to 1, y equal to minus 1, z equal to minus 1. If you look at the options, x equal to 1 is there in option A and D. So definitely B and C are wrong. Y equal to minus 1 is there only in option A. In option B, it is plus 1, so that's also wrong. And of course, Z is equal to minus 1 is there here. So option A is satisfying our answers, that whatever we have got. That's how we are supposed to get the answer. So the most important thing is, while you are solving this problem, this is a repeated question and concepts that you may get an actual question in your REIT examination in this concept that is called principle of homogeneity, which tells you that the dimensions of fundamental quantities like mass, length, and time on left hand side and right hand side are same. That means the powers of the fundamental quantities are same on both sides. That's the most important thing that you need to get from the chapter itself. That's it. Thank you for watching.